Dear all, hello and welcome to Simplified Triple Studies. In this session, I am going to discuss important previous year question which are repeated in the examination. Sub-Engineer-Kerala PSC. The date of exam was on 20th 7 2013. We'll have a brief discussion on previous year question paper. Also, this question will be useful for various type of examination like SSC, RRB, etc. So please go through all 15 questions first. If you want, you can pause the video and answer your choice. Once I'm going to discuss, you can verify the answer. So this syllabus will be for diploma and B level. So you can go through that very easily and mark your choice. Later, you have to verify. So you'll be getting a self-evaluation. So that is why I am scrolling down all 15 questions. All the questions are fundamentals only. Yes, I think it's very clear to everybody. If you want to pause the video and answer accordingly. Later, let us verify how many answers are correct. Okay, so let us go to the first question. Which of the quantity is same in series circuit? You know series circuit? You know that current through all the elements are same in case of series circuit. So you can go for option A. If it is parallel circuit, voltage remains same. Understood, no? This is regarding the first question. The second one is flow of how many electrons per second to produce 1 ampere of current. So you need to calculate the number of electrons. Everybody know that Q is equal to I into T, current into time, that is equal to charge. Similarly, we have one more equation, Q is equal to N into E. So if you equate these equations like 1 and 2, then we can write I into T is equal to Ne. From this, you can calculate N. N is equal to I into T divided by E. Here you can see 1 ampere current they have already given. So let me write 1. What is the time? Time is equal to 1 second. Divided by what is the charge of single electron? 1.6 into 10 to the power minus 19 coulomb. I would like to solve this. It is becoming 1 by 1.6 into 10 to the power 19, right? If you solve, I'll be getting the 6.25 into 10 to the power 10 to the power 80. Okay, you will be getting like you'll be getting in this fashion. So let us go for the first option. The first option is the correct one. 6.25 into 10 to the power 80. All right. Now I'll be proceeding further. Let us have a brief discussion on other questions. In which of the following substances the resistance decreases with the increase in temperature? So there are two types of material. One is positive temperature coefficient of material. Another one is negative temperature coefficient of material. In case of positive temperature coefficient of material, as the temperature increases, resistance also will be increased. Both are directly proportional. But in case of negative temperature coefficient of material like the semiconductor material, as the temperature is high, the value of resistance comes down. So here we can see copper, silver, constant, and all are positive temperature coefficient of material, where carbon is negative temperature coefficient of material. So please select option D. Option D is the right answer. I think it's clear to everybody. A 200 watts bulb and 100 watt bulb, both are connected in series across 220 volt supply. The power consumed them will be, how to calculate? So we have two bulbs. So one is 200 watts, another is 100 watts, right? Both are in series. So there is a supply voltage. How much we have to give? 220, right? 220 volt. Fine. So don't choose the answer directly like 200 and plus 300, that is equal to 200 plus 100 is equal to 300. That is a wrong answer, but because most of the people will be directly adding those power. It is not possible because the internal resistance of individual bulb will be different. So you don't add 200 and 100 watts bulb directly. If you add like that, your answer will be wrong. So what you can do is you have to consider the internal resistance. Like we have to calculate the R1 and R2. We have to calculate it. Let us calculate R1 and R2. What is R1? R1 is equal to, how to calculate R1? So we have one equation according to Ohm's law. P is equal to V square by R. Therefore, R is equal to V square by P. So if you follow the equation, then R1 is nothing but R1 is equal to, what is V? V is equal to 220. V square divided by P is equal to 200. Similarly, R2 can be written as V square. V will be same only. V square by P. V is equal to 100. Now, what I'm going to do is, we have the equations. How to calculate the power? So, power is equal to same current, no, series circuit. I square into R1 plus I square into R2. So, let us take I as a common factor. I square into R1 plus R2. So if you simplify, what is I? How to calculate I? So I you can calculate it. So I is nothing but V by R equivalent. V by R equivalent. So what is R equivalent? V divided by R equivalent is nothing but R1 plus R2. It will be around 0.3. You will be getting around 0.3 amps. So 0.3 the whole square into R1 already available, 220 square by 200 plus 220 square divided by 100. So try to solve this. You will be getting around 65.5 or 66.6 watts you will be getting. That is approximately equal to 66. So better choose option C. Option C is the right answer. This is the way how to solve this particular problem. Here you have to remember that internal resistance of individual load will be different. That point you have to take into, you have to be taken into consideration. If you did not take that point into consideration, absolutely the answer becomes wrong. Fuse wire is made up of, it is usually made up of with tin and lead. Okay, we never prefer tungsten, copper, nichrome, etc. As per the IE rule, better go for the combination of tin and lead. That is the better choice. Option D is the right answer. If VWQ, V means voltage, W means work done, Q means charge. Stand for voltage, energy, and charge. The voltage can be expressed as. So we have one equation. V is equal to W by Q. V is equal to W by Q, where W is known as work done or energy, Q is the charge, V is the voltage. Or we can write W is equal to V into Q. Okay, this is also possible. Or we can write V into, instead of Q, we will be writing I into T. So we can write V into I into T. So you know what is V into I? It is power into time. Therefore, energy is equal to power into time. So which equation is the right answer? C. C is the right answer. So dV is equal to dW by dQ. So we can go for this particular right answer. I think it's clear to everybody. Moving further, two identical capacitors are connected in parallel and charged to potential of V volts. They are separated and connected in series. The potential of combination. It is very simple question. Initially, two capacitors are charged and both are in parallel. Therefore, the total voltage become V. Then what you are going to do is you are going to charge in series. Okay. Then what is the voltage across each element? It will be V only. Correct, no? Okay. So what is the total voltage? V is equal to V plus V. That is nothing but 2V. So 2V is the right answer. Hope it is clear to everybody. So moving further, retentivity is maximum for. So retentivity to hold the magnetic property. For example, we can say a BH curve. If you plot a BH curve, so we have magnetic flux density, okay, then magnetic field strength. If you plot a BH curve, then initially we'll be getting almost linear relation up to the saturation. Then if you reduce the value of magnetic field strength, the B will not come to 0. So B will be holding up to this point. This is called residual magnetism, or what I can say, retentivity. So here the DH curve will be like this only. We have to explain about coercive force, coercivity, all those things. However, you must have studied about the voltage building up of generator. This is very essential for voltage building up of generators. So here the retentivity is maximum for the steel element. So you can go for option D. Option D is the correct answer. I think it's clear to everybody. Okay. So question number 7, that is clear. So steel material is the best one. So two coils L1 and L2 are placed together such that the magnetic flux in one coil is completely linked with another. That means the coefficient of coupling. Here we can write coefficient of coupling is equal to 1. The mutual inductance between the coil. So we have one equation, K is equal to M divided by square root of L1 and L2. Here coefficient of coupling is equal to 1. So M divided by square root of L1 into L2. Therefore, M is equal to square root of L1 into L2. So the right answer is option B. So go for option B, square root of L1 into L2. Very simple. So coefficient of coupling for ideal condition, that will be 1 only, but practically it never be possible. The peak value of 40 volt sine wave. What is a peak value? Consider a sine wave, right? So the peak value will be in this fashion. This is your peak to peak value, correct? No? So we have to calculate the peak to peak value. We have the RMS value, that is equal to how much? 40 volt. So we know that VRMS is equal to VM divided by root 2. Therefore, VM is equal to root 2 into VRMS. That means root 2 into what is VRMS? 40. But we require peak to peak. So till here I have got it as 40 into root 2. I need up to this point. So 40 root 2 plus 40 root 2. Okay. That is equal to 80 into root 2. If I solve 80 into root 2, I'll be getting around 113 volt. Correct, no? So this is actually the right answer. So you need to know the relation between RMS value and peak value. Then you need to know what is the concept of peak to peak voltage in a sinusoidal waveform. Okay. And now moving on to question number 10. When two quantities are in quadrature, if two quantities are in quadrature, the phase angle between the two quadrature will be absolutely 90 degrees. So please select option C. If two quantities are in phase, means the phase angle will be 0. If two quantities are out of phase, means phase angle will be 180 degree. Here, go for option C. It is quadrature. Question number 11. In RL series circuit, power factor will be always lagging. In RC circuit, power factor will be always leading. So question number 12. In phasor form of capacitive reactance. So in case of capacitive reactance, we know that XC is equal to capacitive reactance, correct, no? Capacitive reactance. Okay. So I is equal to V by XC. I is equal to V by XC. So this is a general formula. If I talk about the capacitor circuit, let us take voltage as reference. The current will be always leading. So let us take this is 90 degree, correct, no? 90 degree. So if I take the ratio V by XC, okay. This is a general formula. From this you can calculate XC. XC means V by I. V by I. That means V by IC. Okay. Here the voltage, there is no phase shift. So let us take 0 degree divided by IC means we can write IC angle plus 90 degree because current is leading. So let us solve V by IC. So if you solve angle, it becomes 0 degree minus 90 degree. What is the answer? V by IC into angle minus 90 degree. So the answer is XC angle minus 90 degree. So V by IC means XC only. XC angle minus 90 degree. So you can go through option B. Select option B. So I think you got the concept. Now I'll be moving on. Question number 13. So please check the question number 13. I think the concepts are clear to you. The algebraic sum of instantaneous phase voltage in three-phase circuit will be always zero only. Okay. You need to study what is balanced condition, unbalanced condition, all those things. Option C is the right answer. The relation between line and phase voltage in delta connection. So remember that line voltage will be is equal to always phase voltage, but line current is equal to √3 into phase current. That is the relation in delta. Delta is suitable for high current and low voltage application. So this point you have to remember. Okay. Now last question. The line current in balanced delta system is 17.3. IL is equal to 17.3 ampere. What is I phase? I phase I have to calculate it. So we know that IL is equal to √3 into I phase. Therefore, I phase is equal to IL divided by √3. So IL is how much? IL is 17.3 divided by √3. So you know the value of √3. So 17.3 divided by 1.73. So that is nothing but 10 ampere. So these are the most basic question fundamentals because for a competitive examination, you should have a good foundation. So you need to know how to apply the equations. Okay. So let me know if you are having any queries. I'm very happy to answer. Thank you for watching this video. The remaining part will be discussed in the next session. Have a great day. So if you are watching the channel first time, so please do subscribe and you'll be getting all the updates. Have a happy learning. Have a great day.